Hello everyone and welcome to my latest Rust Quickie. In my previous Rust Quickie I have talked about the heap, and today I want to continue that discussion by talking about so-called move operations which happening in Rust when you are allocating memory on the heap. So let's switch over to Visual Studio Code, where I want to demonstrate move operations in more detail to you. I have here a very simple function which I have implemented. It's called moves, and within that function I want to demonstrate now move operations to you. As you can see in the first step, I'm just allocating here with the function string from a string on the heap, the string hello world. As you know from my previous Rust Quickie, Rust internally just allocates that memory directly on the heap, and a reference to that memory location is stored in the local variable s, and that local variable s is stored in the stack frame of the current function. And what we are doing in the next step is quite simple. I'm assigning that variable s to another variable called t, and then we're just using the print line marker to print out that string. So let's run that. Let's do a cargo run command, and as you can see, we're just printing out that string hello world. Everything is good so far, but imagine now the following. In the next step, I also want to print out the variable s, so the original variable where we have allocated that string on the heap. And as you can see, we are getting here now by the Rust compiler a compiler error. Rust isn't able to compile that program for us. So when we do a cargo build command, you can see we have an error when we scroll up, and when we find the error message, you can see here now from the Rust compiler we have a problem. Rust doesn't compile that program. Why? Well, it's very easy to understand. As soon as you are allocating memory on the heap, like in that case here, that memory can only belong to one possible owner. Means, in the initial case, the owner is the variable s. But in the next step, we transfer that ownership from the variable s to the variable t, and that transfer is called a move operation. So afterwards, the variable t just points to the string on the heap. But what happens to the variable s? Well, more or less, the variable s is uninitialized. Just think about it like a null pointer in C and C++. We are just moving the address from the heap location from the variable s into the variable t, and afterwards the variable s is just uninitialized, and therefore we can't access that variable afterwards anymore. And therefore the Rust compiler generates you here a compiler error. Means you can't compile that program anymore, because that variable s is more or less just uninitialized. So this is very important when you're working with data structures that you are allocating on the heap. As soon as you're assigning that pointer to the heap allocated memory to another variable, the initial variable is just uninitialized. This is very important, and this only happens when you're working with heap objects. An object that you are allocating on the stack doesn't have that problem, because the stack is always specific to that function, and therefore Rust doesn't have to do those move operations. So those move operations are only happening when you are working with heap objects. Another area in Rust where move operations occur is when you're working with function calls. Imagine we're creating here a new vector. That vector is again allocated on a heap. Afterwards we are pushing 3 string values into that vector, and then I'm calling here a function called print vector, which just prints out the individual entries of that vector. And as you can see, we are passing in that vector, and inside that function I'm just iterating over that vector, and I'm using again the print line macro to print out the individual entries. The problem is now, as we have said, that variable databases, the vector, is allocated on the heap, and therefore when we pass that reference to the heap into that function print vector, the ownership of that heap memory is transferred to that parameter of the function. Means afterwards, when we have executed that function print vector, our original variable databases has no value anymore. As you can see, when we try to access that variable databases after that function call, we get again a compile time error by the Rust compiler because a move operation has occurred. Means we have just transferred the ownership of that variable databases into the local variable string vector of the function that we have called. So when we try to build that program again, you can see that we are getting again an error message, because we are trying to access a variable which has no value anymore. So this is also very, very important when you are passing references to heap allocated memory to a function. Then a move operation occurs within Rust. Another interesting problem in combination with move operations in Rust is the use of functions. As you can see, I'm defining here a vector. That vector is again allocated on the heap, and we are storing in the variable x just a reference to that vector. And afterwards, I have here a very simple for loop. We are iterating a few times, and during each iteration I'm calling here a function fn1, which I have defined here. And as you can see, that function accepts a vector which was allocated on the heap as an input parameter, and I'm passing in that vector x that we have allocated here on the heap into that function. Imagine what happens here. When we are doing that function call the first time during the first iteration of that for loop, we are moving the owner of that vector into the input parameter of that function. This means when that function call has finished, our variable x has no value anymore, because the ownership has been transferred into that input variable of that function. Means after the first function call, the variable x is more or less just a null pointer. You can't access that variable anymore, and therefore the Rust compiler generates you here again a compile time error. So this is very, very important when you're working with heap allocations in Rust. You can only have one possible owner for heap allocated memory. That's the outcome for today's Rust Quickie. The question is now, of course, how can you solve that problem? Imagine you want to call a function and afterwards you want to still be able to reuse that variable. Well, that's possible. In Rust we have so-called references which make that possible, and I will talk about references in my next Rust Quickie. I hope that you have learned today a lot about move operations in Rust, and I'm already looking forward to see you next week again. Thank you and stay tuned.